Okay guys, so on to research methods. As a whole, the greatest way for students to lose marks across the whole section was not to justify either the level of data, the design, or the test of difference, association or correlation using the STEM. If you think about it, you could get a 5, a 6 or a 7 mark question just getting you to justify use of a stats test. So think about how much you have to write in an essay to gain that many marks. There is no way that you're going to get away with writing single words, is there? So my number one piece of advice is to make sure you write enough in these questions, because loads of you are not, and you're not using the right format. You're not, when you're writing statements of significance and things like that, you're not always writing in the expected format, so that's well worth practicing. Right, so that's my kind of overall advice. So let's go through it question by question. So number 9, very few of you seemed to recognise that this was actually a correlational study, that it was investigating a relationship, which is really weird because the first few words are the researcher wanted to test if there is a relationship. So if you know that their word relationship is there, you instantly know that you are looking for a correlation. Yeah. Now, the passage of time and the recall of nonsense words. So we already know we're looking for a correlation. It's either Spearman's or Pearson's. So the only option now is how you're going to justify the level of data. I would probably say that the passage of time is interval because it's going to be measured on a stopwatch. And the recall of nonsense words, well, either you recall them or you don't. It's a fact, it's an objective fact. They either get it right or they don't. These are going to be written down and easy to mark. So in my opinion, it's very clearly Pearson's. However, if you justified the recall of the nonsense words as maybe self-report or something like that, or you said there was they were made up words or whatever like that, it was going to be more of a subjective measure, something like that, then fine, you can argue Spearman's, acceptable. That is on the mark scheme. So the 5 marks were 1, Pearson's or Spearman's, 2, because it's a relationship, we're looking for a correlation between the passage of time and recall of nonsense words. So relationship and then STEM. And then the final 2 marks were for the type of data. So it's interval data because the number of words recalled is objective and the amount of time is objective. So if ever you're justifying interval data, the word objective should be there. If ever you're adjusting ordinal data, the word subjective should be there, okay? I've written down students are failing to explain why it is interval. That's like the number 1 mistake. There's also a lot of confusion about what chi-squared is used for. It's not a test of correlation. It is not a test of correlation. You've all been told about that table, about Simon Cowell and all the rest of it. Chi-squared is only used as a test of association with nominal data. You can't correlate nominal data. You also, big mistake, cannot have a research design in correlational studies. So those of you who have tried to say that this is a repeated measures design because they were tested many times, this isn't a test of difference, there's no design. So correlational studies have less justification points than tests of difference. So they're going to take marks away if you start saying that there's a research design here. Correlations never ever have a research design, ever. They can't. You're looking at how 2 things are related, how they compare, not the difference between 2 things. It's a completely different scenario. Okay. Number 10, this is what I've written. There's an issue with the standardised layout of students' responses. So you aren't all using the right layout for your response. I will explain when I see you in person, but basically it's you state the test, that's already been stated for you, and then you should have, like, you can even number them 1 to 3 or bullet point them. So, well, because it's a test of difference between 2-year-old and 4-year-old children's type of play. So that's number 1. 2, it's an independent groups design, because I can't be both 2 and 4 at the same time. I'm kind of shoved into one of the groups. And 3, it's an what's the type of data? Oh, it's interval data, because it's interval data, because I'm measuring in time how much of that 15-minute interval is spent on each play type. Yeah? Lots of you incorrectly said because it's a 15-minute interval. Well, but that isn't actually what they're measuring. They're not measuring the 15-minute interval. They're measuring how much of that 15-minute interval is being spent on each play type. So be really, really careful when you justify, basically, is what I'm saying. Basically the marks are constantly being lost because you're not citing the STEM extensively enough. And you can't use one justification across 2. So you can't write, it's a test of difference between 2 and 4-year-old children and therefore an independent groups design. You can't tie all that together. You have to justify every single thing separately. So you didn't always do that, and that it's just easy marks lost here. Now these 2 questions together, 9 and 10, were worth 11 marks, and they probably only took you 5 minutes. It's just such a shame, because that could be a whole grade. So just be so, so careful. Lots of you said things like they are only observed once to justify an independent groups design. That's not enough, okay? What are the 2 independent groups? So you're either a 2-year-old or a 4-year-old. It's not enough just to say you're only observed once. That's just the standard definition of an independent groups design. You have to relate it to this STEM. So you're either a 2 or a 4-year-old. Also, interval data incorrectly justified as 15-minute intervals. I've said that. Be really, really careful. And I will show you on the PowerPoint how to lay out the question effectively. Okay, now, moving on. The next bit, it got better, to be fair. Most people were very, very good at question 10, part B. So the calculated value of T, 3.576, is greater than the critical value of 2.101. Therefore, there is significance at the 5% level. Very, very good. The only mistake that some of you made is you didn't read that statement below the table carefully, and you got things the wrong way round. So just be very, very careful. Now, part C is one of the worst answered questions in the whole paper. Lots of you are still completely misunderstanding errors. When you tell me what a type 1 error is, you don't justify a type 1 error as being more likely to take place at the 0.1 level or the 0.05 level. They don't want to know about that. You have to tell them about the hypotheses. So a type 1 error, first mark, is an error of optimism. It's when you think you found something but you haven't. So in terms of hypotheses for the mark, you accept the experimental when you should have rejected it. Okay, that's the first mark. But the rest of the marks for this question are available by using the STEM. So you go to the table. So at the 5% level, there's only a 5% risk of making a type 1 error. That's what that level means. So tell me that. But if you look at the 1% level, which is 0.01, it's still significant, because 3.576 is still greater than 2.878. So we've still got significance. That means there's only a 1% risk that we've made a type 1 error, okay? I just feel that some of you are still misunderstanding errors, so there will be practice. After we finish the course, we're going to do a lesson on errors again. Then question 11. This was bizarre. I mean, I'd say maybe only a quarter of the year group got this right. It's very clearly nominal data. I'm not quite sure how you got the level of data wrong. So you're literally just counting up how many people there are in a category. So how many people smoked in 1987 and how many people didn't, and how many people smoked in 2017 and how many people didn't. It's literally just counting up, tallying in categories. So it's very clearly nominal data. It's very clearly an independent group's design, because it's not the same people in 2017 and 1987. It's different people. It just says a similar survey of another 1,000 young people. So it's not the same. So it's an independent group's design. Nominal data, it's a test of difference between smoking behaviour in 1987 and 2017. So it's chi-squared. Okay? There was all sorts of justifications. Every single statistical test that we have looked at, all 8 were across the spectrum there, but there were no marks for anything other than chi. You could obviously pick up marks for identifying test of difference and nominal data or whatever, but there's only one possible answer. Now, question 12, remember you get working out marks. The only issue is with these working out marks that the examiner cannot see any notes that you make to the table. So where you've gone down and scribbled pluses and minuses down the table, I can't see that when I'm a real examiner in June. I can only see the lines that you've written on under Part A. So I can only give you working out marks if that working out is written on the lines. So what I needed to see was the number of minus signs and the number of plus signs that you identified. Some people were doing really weird things like taking one away from the other and goodness knows what. I mean, it's such a straightforward question. You just count up the number of positives, the number of negatives. S is the smallest number, so S was 3. And obviously you've got rid of your 0 values. They're dead to us. Don't pick the 0 value, okay? It wasn't 2, that's gone, it's dead to us. That's why I was so elaborate in lessons about making you kill them and draw a line through them. We get rid of them. Do it in your exam paper. Lots of you did, you crossed them all out. Okay, and then we have the, but if you didn't have working out, the mark scheme says I should still give you full marks. That's not often, that's very generous of the exam board, so always put your working out there, okay? Part B, the answer was there was no significance. Even if you'd got the S value wrong, I could give you marks as long as you identified the critical value in the table where N is 8 as 0. As long as I can see the critical value is 0 and therefore there isn't significance, I can give you 2 marks, all right? So that's research methods. It's the most important part of the whole A-level. I cannot tell you that this cannot be underestimated. You might open paper 1 and the sign test or chi-squared or Wilcoxon, the first page and a half of paper 1 might be stats. It can literally turn up anywhere. Any of this, and it will. There's normally at least one stats related question in every single paper, at least. Obviously paper 2's got hundreds of them, but it just comes up absolutely anywhere. Up to 40% of your A-level could be research methods. And a lot of it, the majority, is going to be this stuff, all right? So make it your strongest. If it's not, practice, get mark schemes, get exam papers off the website. You've got the link on your Google Classroom and just keep practicing. The only way to practice stats is to learn stats is practice. You can't rote learn like you do theory. Okay, I'm going to stop because it's 14 minutes.